Welcome to Interstellar Voyage, your gateway to the mysteries of the cosmos. Here, we explore the most fascinating enigmas of the universe: UFO encounters, abduction stories, alien civilizations, and the unexplainable phenomena that cross Earth's skies. Each video is a deep journey through real accounts, surprising investigations, and theories that challenge everything we know. If you're passionate about science, space curiosities, and extraterrestrial phenomena, this is the place for you. Get ready to embark on a journey where the boundaries of reality are tested and the unknown has a voice. Subscribe, turn on notifications, and join us on this odyssey through the universe. The universe reserves unique and fascinating spectacles for us, and one of them is about to unfold in our skies. Vesta, one of the largest and most intriguing asteroids in the solar system, will make a special approach to Earth in mid-May, offering experienced observers a rare opportunity to contemplate this rocky giant that orbits between Mars and Jupiter. What is Vesta? Vesta is no ordinary asteroid. Discovered in 1807 by German astronomer Heinrich Olbers, this celestial object possesses unique characteristics that make it fascinating to the scientific community. With approximately 525 kilometers in diameter, Vesta is the second largest asteroid in the main belt, surpassed only by Ceres, which today is classified as a dwarf planet. What makes Vesta truly special is its composition and structure. Unlike many asteroids that are merely conglomerates of rock and metal, Vesta has a differentiated structure, with core, mantle, and crust similar to rocky planets. This characteristic suggests that in the distant past, Vesta came very close to becoming a protoplanet, with its development interrupted by Jupiter's gravitational influence. Vesta's approach to Earth in May represents a less common astronomical event that deserves special attention. Although Vesta completes an orbit around the Sun every 3.6 Earth years, not all approaches offer ideal observation conditions. Factors such as the relative position of Earth, the Sun, and the asteroid, plus lighting conditions, determine viewing quality. During this approach, Vesta will be positioned in the constellation Libra, a sky region that offers excellent observation conditions during certain nighttime hours. The asteroid's apparent magnitude during this period will make it visible through adequate astronomical equipment, although it remains invisible to the naked eye. Observing Vesta requires careful preparation and intermediate to advanced astronomical knowledge. Unlike bright planets such as Venus or Jupiter, which are easily identifiable, Vesta appears as a faint point of light that moves slowly against the stellar background. The first step is familiarizing yourself with the constellation Libra and its location in the night sky. Libra is situated between the constellations Virgo and Scorpius, being best observed during spring months and early summer in the southern hemisphere. The constellation is relatively discreet, without particularly bright stars, making the use of star charts or astronomy applications essential. For successful Vesta observation, some equipment is indispensable. A telescope with minimum 80 mm aperture already allows asteroid visualization, although larger telescopes offer better image quality and facilitate identification. Astronomical binoculars can also be used, especially models with 10 by 50 magnification or higher. Besides optical equipment, an updated star chart or reliable astronomy application is fundamental. Apps like Sky Safari, Star Walk, or Stellarium Mobile provide precise real-time information about Vesta's position, greatly facilitating its sky location. A red-filtered flashlight is essential for preserving night vision during observation. The red filter allows reading charts and adjusting equipment without compromising eye adaptation to darkness, crucial for detecting faint objects like asteroids. Asteroid observation requires patience and specific technique. Vesta moves slowly against the stellar background, completing its apparent movement over days and weeks. To identify it with certainty, it's necessary to observe the same sky region on consecutive nights and notice which star changed position. The most effective method is creating a drawing or photograph of a region where Vesta should be, comparing with observations made on different nights. The asteroid will be the only object that changes relative position to the fixed background stars. During observation, it's important to use moderate magnifications. Excessive magnification can make the object too faint and difficult to locate. Magnifications between 50x and 100x generally offer the best balance between brightness and identification capability. The ideal time to observe Vesta varies according to its position in Libra constellation and May's specific period. Generally, the best conditions occur when the constellation is high in the sky, away from the horizon and denser atmospheric pollution. For Southern Hemisphere observers, including Brazil, Libra is best visualized during early morning hours in May. The asteroid will be in its most favorable position between 10 p.m. and 3 a.m. local time. The constellation reaches its culmination, highest point in the sky, around midnight, offering ideal optical conditions. In the Northern Hemisphere, including the United States, Canada, and Mexico, the situation is slightly different. North American observers will have better viewing conditions late at night and early morning, approximately between 1 a.m. and 5 a.m. During this period, Libra will be in a more favorable position in the eastern sky, although the constellation appears lower on the horizon compared to the Southern Hemisphere view. Observers at more southern latitudes in the United States, such as Florida, Texas, and California, would have superior conditions to those located further north. Latitude difference significantly affects Libra constellation's apparent height in the sky. While Brazilian observers will see Libra pass near the zenith, point directly overhead, North American observers will see it at lower angles, especially those located at latitudes above 40 degrees north. This difference means North American observers will need to consider greater atmospheric interference and have unobstructed southern and southeastern horizons. Clear atmospheric conditions are essential for both hemispheres. Cloudless nights with low humidity and away from urban centers offer the best opportunities. Urban light pollution can make detecting faint objects like Vesta impossible, this factor being particularly critical for North American observers, who already deal with the disadvantage of the constellation's lower apparent height. Observing Vesta offers a direct connection to solar system history and formation. This asteroid preserves characteristics from a planetary formation period approximately 4.6 billion years ago. Its rocky surface and mineralogical composition provide clues about processes that shaped rocky planets. Recent space missions, such as NASA's Dawn probe, revealed fascinating details about Vesta. The probe discovered that the asteroid has mountains higher than Mount Everest and gigantic craters that expose its interior. This data transformed our understanding of this object and its importance in the solar system context. Experienced observers can attempt more sophisticated techniques, such as astronomical photography of Vesta. Using CCD cameras or DSLRs adapted for astronomy, it's possible to capture asteroid images and document its movement throughout nights. Asteroid photometry, measuring its brightness over time, can reveal information about rotation and shape. Although it's an advanced technique, dedicated observers can contribute valuable scientific data to the international astronomical community. Vesta's approach in May represents a unique opportunity for experienced astronomical observers to expand their knowledge and skills. This event connects us directly with the solar system's primitive history and demonstrates how amateur astronomy can provide genuine and meaningful scientific experiences.